right, so I'm gonna actually record this so for you and Adeline, because I know you guys have a test next week on what, Tuesday or Wednesday?
I have it on Tuesday, but I'm going to take it on Thursday and Friday instead because Tuesday I have to leave school early because of cheer.
Okay, so that means we can actually meet on Wednesday to review. But I'm
Yes.
gonna give you everything
Okay.
up front, and it should be enough for you to start practicing it on your own.
Okay.
Okay, so the first thing, okay, so let's represent what this is about. These are our trig graphs, and we're gonna do all of them at once. Now, as a disclaimer, well, I don't know, it's not a disclaimer, but some of the stuff that I'm going to show you is going to be slightly different than Mrs. Town's method,
Okay.
but from what students tell me, this way is way easier, and I always find the easiest way. Okay, so to stick to you want to stick to one, or else you are gonna get mixed up during the test. Okay.
Okay.
All right. The first thing we have to learn is just the shape of the graphs. You have to memorize the shape. So when you see something like y equals sine x, uh, um, the way you graph these, it's pretty much the same in terms of the shape of it. You always put 5 dots on the x-axis. 1, 2, 3, 4, 5. Again, we'll fill out the numbers later. Okay. Some teachers always do the ideal numbers like 0, pi over 2 pi, 2 pi over 3 pi over 2, and 2 pi, but you don't need to do that for right now. Just always think of it as 5 dots with 4 segments. 1, 2, 3, 4.
Okay.
Sine always has this pattern. We'll call this middle, right? So it starts in the middle, and then you go up, middle, down, middle. Okay, so up, middle, down, middle, and then you trace it like this. Okay.
Okay.
So just memorize the shape right now. Now, if your teacher says graph two, okay, one full graph is called one period. So this right here will be one period graph. Sometimes they'll say graph two what? 2 periods. Well, just go the opposite way. And again, start at this dot and draw 4 dots evenly spaced out. 1, 2, 3, 4. And then just do the pattern again. Middle, top, middle, down, middle. And there's 2 graphs right there. Okay? All right, now watch this. With sine graphs, you can also graph the cosecant graph, the cosecant of x. And the reason yeah, say it again?
You okay, I'll start recording. I don't think I started it.
Oh no, I'm not recording on Zoom. The quality's not as good. I'm gonna do it on. I'm just doing it on my computer so that your face won't show. It'll just be me.
Oh, okay. Sorry. I thought I had to click
yeah, and the quality will be much better too. And then I'll send you the YouTube link when I upload it later. Okay.
Thank you.
All right. So you're gonna see this. Like your teacher will say, graph a cosecant x graph. Well, what you have to realize is graphing a cosecant x graph is the same thing as graphing a what?
The sine graph?
So what you actually have to do is graph the sine graph, which is this, and then do 2 more steps. Those 2 steps are these. You want to cut these up into like cereal bowls. You see this little cereal bowl right here?
Yeah.
Okay. So draw a dotted line, like slice it up right here, right here, right here, basically just everywhere. And then take that bowl and flip it the other way, like this, and draw 2 arrows. You see that?
Okay.
And then right here, same thing. Do it like this. Now make sure you connect at the vertex right here.
Okay.
Okay, so this will swap over, and they're just gonna go right down to the side of the asymptotes. So there it goes. Okay, so the blue graph is your cosecant graph. The gold is your sine, but you realize in order to graph the cosecant graph, you always have to start with the sine graph what?
First.
Sine graph first, okay? And the same goes for cosine. So let's look at the cosine graphs. Y equals cosine of x. And again, you break this down into four segments with 5 dots. So 1, 2, 3, 4, 5, evenly spaced out. And then I'm just going to go 4 on the other way too. So 1, 2, 3, 4. Okay. And then, so what's the pattern for cosine? the pattern for cosine is we're gonna start at the top. Okay. So we put a dot up there, and every time we switch over like a segment, it's gonna go top, middle, down, middle, top. Okay. So again,
Okay.
top, middle, down, middle, and what?
Top.
So just mark those points: top, middle, down, middle, and top, and then you graph like this. Now, you want to make it curved. You don't want to make it look like a V. Like don't make it into a V, okay?
Okay.
Because the wave continues on. So if you go to the left side, it's the same thing. I'll do this with a red color. So top, middle, down, middle, top, and it goes like this.
Top, middle, down, middle, top. Okay.
Yeah.
Oh,
Okay,
so you
so-
would connect it.
Yeah,
Okay.
so when you get to the top, you want to like curve it because it's going to come back down.
Okay.
So again, if you keep going, it's the same thing as a sine graph, except that it's been shifted over a little bit. So now, okay, so the question is, well, what if the teacher wants you to graph a secant x graph, right?
Mhm.
Well, you start by drawing a cosine graph, and then what do? Cut it up into what?
Into the
Continuous-
halves?
Yeah, into the bowls or whatever.
Oh, okay.
Yeah. This. Yeah, and then you see at the end of the cosine, you want to draw it out like this because the graphs will, I mean,
Oh,
the wave will
and-
keep going,
Okay.
and then just flip it upside down, and voila, you have your secant x graph. Okay. Okay, so right now all we did was just memorize the shape of the graph, and that's the most important thing. Every translation and formation of these graphs will always follow the exact same shape.
Okay.
5 dots, four little segments, and just follow those patterns. Like if it's sine, what was the sine one? Middle, top, middle, down, what? Middle?
Mhm.
That's, and then cosine will be top, middle, down, middle, what?
Top.
Top. Okay. Now, what do you call this? Like this height of this wave? When the wave kind of goes to the top and comes down, what do you call this height? Do you remember from class?
Is it the? It's not
Starts
the
with an A. Uh-huh.
amplitude.
The amplitude, right. Okay, so this right here is called the amplitude. The amplitude is a positive number. So because it's just a number that says it goes up and it goes down this way. And I'll show you later where the amplitude is
Okay.
in the equation. Okay, so amplitude is just the height of the graph and the depth of the graph. One period is one length of a what?
One length of an amplitude.
No, one length of a whole graph. Well, we call it one cycle. Okay,
One.
it's
Okay.
basically like a ruler length of how long one wave is. Okay.
Okay.
All right. So okay, now we only have two more left. So we learned sine, cosine,
Mhm.
and the respective reciprocals. Well, technically that's 4. And now we just have two more, a tangent and a cotangent. So these two are actually really, really easy to graph. Y equals tangent of x, and y equals cotangent of x. All right. So tangent of x, how do you graph this? Well, just draw your x and y axis, and always draw an asymptote at pi over 2 and negative pi over 2, and make a dotted line, dot, 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 dot.
Would it be the center of the graph or no? Or like
The center will be, yes, right here, yeah. And then now this length right here, again, break this up into four segments, 4 equal segments.
Okay.
So you'll do like you put the middle there, and then the 1/4, 1/2, 3/4. So put like 3 dots, and you'll create like 4 segments. 1, 2, 3, 4. See it?
Okay.
Okay. Now tangent graphs are really simple. Tangents don't have an amplitude. I don't know why teachers sometimes say that there's an amplitude, but you see this number in the front of the tangent right here, this 1?
Yeah.
Okay, it's not an amplitude. Some teachers for some reason call it that. Now, I'm gonna use this one to graph this. And how? Well, you go one segment to the right and left of the center, and on this guy right here, just go up 1 unit, which is like right here. And on this side, go down 1 unit, like that. And
Oh,
guess
okay.
what? That'll show you how to graph it proportionally, or like the stretch and all that. So go like this. This. So you have to memorize that tangents are right side up, left side what?
Right side up and left side
Left
down.
side down. Uh-huh. Now, if you're given like a negative tangent,
Hmm.
okay, then you just go the other way. Left side up, right side what?
Right side down.
Yeah,
Okay.
right side down. Okay. So again, so if this number in the front was like a 3, so let me erase that and put a 3 right here. If that was a 3, then all you have to do is just go up 3 units. So you go 1, 2,
Oh,
and
okay.
3. So the graph will be like thinner. Okay, it will
Yeah.
stretch. 1, 2, 3, and so you'll trace it here like that. Okay.
Okay.
So that's all it is. It's just a way of like kind of like proportioning out the graph based on the vertical stretch. Okay, but it's not an amplitude, but I know some teachers call it that. Very confusing. But okay, so the point right now that I want to make is that the period right here, this is one period, okay? This is one full length of a graph, and the period is pi. Okay?
So the period is pi.
Yeah, the
Is
period
that
is pi.
sorry, is that same for the negative and the positive?
Yes, negative and the positive. All tangent and cotangent, the period is pi.
Okay.
It's just that you have to memorize these two numbers. These two numbers are the most important numbers for these tangents. Negative pi over 2 and what?
Over 2?
Yeah, you have to memorize those, okay?
Okay.
And I'll show you why later. And then cotangent. Now cotangent just goes the other way, but here. So it shifts to the right. So the asymptote is right at x equals 0, right here,
Okay.
and at pi. Okay, and then find the center, and then break it up into 4 segments again. And this one, we're going to go up 1 on the left, down 1 on the right, and we're going to graph it like this. Okay, so cotangents are up left, or left up, and right what?
Right down.
Right down. Okay.
And then the middle one would be pi over 2, right?
Oh yeah, middle, yeah. Now I'm going to show you a real easy way to figure out these numbers.
Okay.
Yeah, it's going to be really simple. So again, we'll go step by step. So for this one, you have to remember that the asymptotes are at 0 and pi.
Mhm.
Okay,
So 0
0
for
pi?
cotangent, right?
Yeah, for cotangent, and then for tangent is from negative pi over 2 to what?
To pi over
Pi over
2.
2. Yeah, so those are the only two numbers you really just have to memorize, and then the rest will just kind of like fall into its place. Okay, and again, the period for cotangent is also what? 1 pi, okay?
1 pi, okay.
Yeah. Now the period for sine and cosine is going to be 2 pi, but I'll show you in a bit. Okay, now let's just jump in and start graphing. Let me pull up some graphs.
Okay.
Um, okay. Oh, I've done it wrong. Okay. Okay. All right, so I was on the wrong chapter. I kept looking for graphs. Found it. All right. So you're like, oh, okay, that's the first expression that you have, right? Like, oh, like what is this? Okay, now we're gonna take this apart. It's gonna make it really easy. First of all, we know that it's a what?
A sine graph?
Yeah, and we know the shape of it, so it's just this, right?
Yeah.
So it's gonna look like that to a whatever extent. It's gonna either be like higher, like thinner, wider, whatever. Okie dokie, here we go. Now, I'm gonna write the equation out like this. Y equals a sine parenthesis bx plus C plus D. Now, okay, A is the number in front of sign. So A right now represents 1/2. Got it?
Okay.
Okay, so let's just identify these numbers first. So A is 1/2. B, okay, now I know you don't see a parenthesis here, but you can actually just add one. Okay.
Oh, okay.
B is the number attached to X, but not the X. So
So
take a look
pi
right here. So it's pi over 3, right? So just write that down. So A is 1/2. B is pi over what?
pi over 3.
Yeah, pi over 3. Now, C's not here because C is a number that's being added, but since it's not there, you can technically look at it like this, plus 0. You see it?
Plus 0.
Yeah.
Okay.
So C's for like the horizontal shift, and I'll show you that in a bit. And then D is your vertical shift. Okay? Yeah, and don't worry, we'll do one with all of these. And I'm just gonna start off with a really complicated one, and then the rest will just become like, oh, okay, it's not that bad. Okay, so now don't die on me yet. Here we go. Number 1, find the amplitude. So step number 1, find the amplitude. The amplitude is literally the letter A. So it's just 1 what?
1 over 2.
Yeah. Now, if there's a negative sign in front of here, just write it as a positive what? Number.
Oh,
Yeah. So remember, amplitude is neither positive or negative, meaning it's just the distance of the graph, the height of the graph and the depth of the graph. So you always want to present it as a positive number.
okay.
Number 2, find your period. And how do you do that? You have to memorize this equation, 2 pi over b.
2 pi.
2 pi over b for sine and cosine. Okay, 2 pi over b. So what is b? What is b in this case?
Is pi over 3.
So write 2 pi over
3.
pi over 3 and simplify it. Do you know how to simplify this? You have to take the pi over 3 and flip it and
So
multiply it. So that'll become what?
6.
Okay, all right, 6. All right, now the period is not that important. It's the count, and this is where I don't know if Miss Town does this, but she might do something similar to this, but maybe call it something else. I got this just from some teacher that she called it count, so I just ended up calling it count. All you have to do is the moment you get your period, take that and cut it up into 4 parts or divide it by 4.
Okay.
Okay, right, and that should make sense because on the graph, right, if one period of the graph is this long, it's always going to be cut into how many parts?
Into 4.
1, 2, 3, and what?
4.
4. Yeah, and that's what we're doing. Okay, and that number, this number right here, is the most important number. Okay, and I'll show you why. So now, can we reduce this to 3/2?
Yeah.
Yeah. Now keep this in mind. They're equivalent fractions. You can use 6/4 or what?
Or 3 over 2.
Yeah, and the reason I'm showing you that is because sometimes the denominator of whatever's down here will have a 4, so just use 6 and 4. Sometimes the denominator has a 2, so just use 3 over what?
3 over 2.
Yeah, I mean, it's easier to add common denominators. Okay, so number 1, amplitude. Number 2, period, and you use 2 pi over b. Once you get your period, divide by what?
Divided by 4.
4, and you have this thing called a count, which you're going to start counting. And then number 4, the fourth step is find your phase shift or horizontal shift. Does Miss Town call it that? Do you remember?
Yeah, she calls it phase shift.
Okay, now I know for a fact her equation looks like this. C over what?
C over b.
But
Yeah.
don't use that. Use this. Use negative. Just add on a negative sign, and I'll show you why. When you put this negative sign and just simplify this equation, this fraction, whatever number you get is where you start the graph. But if you don't do the negative and just get a fraction, Miss Tan will tell you you have to go the opposite what?
The opposite way.
Yeah. Now, if you can remember that, that's fine. But I don't like to remember things when I'm taking a test. So I like to just get the number that I'm working with and just slap it on my paper. So if you start with a negative, whatever number you get, that's what you're going to put on the graph. You don't have to think about, oh, go opposite or positive, whatever. Okay?
Okay.
So what is it? C would be, okay, in this case, C is 0. B is pi over 3. So this would just be what? 0. There's no phase shift, meaning it's going to start at x equals 0. Got it? Okay. and no vertical shift. And lastly, vertical shift. Well, technically this is first. Just put none. Okay, so amplitude, period, count, phase shift, negative C over B, and then vertical shift, there's none. Once you have these four right here, you're done. You can start graphing. So here we go. Just draw that out. Well, okay, we're gonna do 2 periods. So let's see. I'm gonna draw it like this. And you don't have to draw it to scale.
Okay.
So go to your phase shift. Your phase shift, there's no shift. It's gonna start at 0. So
Yeah.
put 0 right there. Okay, and just plug in 4 dots to the right and to the left, evenly spaced out. 1, 2, 3, 4, and then to the left. 1, 2, 3, what? 4. And just make sure you have 4 segments. Okay. All right. Now, what do you put on those dots? Your count, meaning start counting with 3 over what?
3 over 2.
Yeah. So just go. What's 0 plus 3 over 2? 3 over 2. 3 over 2 plus another 3 over 2 is 6 over what?
6 over 2.
Yeah, and you can reduce it later. 6 over 2 plus 3 over 2 is 9 over 2. 9 over 2 plus 3 over 2 is 12 over what?
Over 2.
Yeah, and 6 over 2, you can reduce that to 3, right? And 12 over 2, you can reduce that to?
To 6.
And there you go. 6 is our period, isn't it? Voila.
Yes.
And if you go reverse order, so from 0, all you do is just subtract the count. Subtract negative 3 over 2. So negative 3 over 2 here, and negative 3, negative 9 over 2, negative what?
Negative 6, sorry.
Okay, we got all those numbers down, and that's like the hardest part. And what's your amplitude? Your amplitude is what?
1/2.
1/2. So on the graph, plot 1/2. Again, I'm going to make it a little bit high. We're not drawing this to scale. So positive 1/2, negative 1/2. And so this is a sine graph. So let's go ahead and do our sine pattern. What's our sine pattern? Middle, top, middle, down, back to middle.
Okay.
So start at 0 at middle, middle, top, middle, down 1/2, middle. And voila, you see it?
Top.
Okay, I'll wait. Did you get this?
Yes, I did top instead of bottom for the last one.
Okay. Now, so when I graph the left side, I start at 6. Like I guess some people you could some people are really good at going backwards, but I just memorized the pattern again. So middle, top, middle, top, middle, down, middle, middle, top, middle, down, middle.
Okay. Middle, top.
It should connect right there. Got it?
Yes.
There you go. That's your graph. And if perchance this is instead of a sine, all of that, it's a cosecant. What?
Cosecant.
Like here, let me just write it separately. What if it was like y equals 1/2 cosecant pi x over what?
Over 3.
Well, you'll graph a sine and then do what? Cut up the poles, right? That. So we flip over here, flip over there, and there. Okay, so the cosecant graph will be all the flip ones.
On so like the first one to the right? Yeah, the first one to the right.
Yeah. So is it?
Oh, sorry.
Yeah, go ahead.
When it says 2 phases, so it technically would only I would only need to do the part on the right or the part on the left, right?
Okay, you mean 2 periods, right?
Yes, 2 periods. Sorry,
So
2 phases.
this right here will be 1 period, and this right here will be 1 period. So we're graphing 2 whole periods of a graph. Yeah.
Okay.
Now on the test, I don't know if she's gonna ask for 1 period or 2, but usually I think on the test they ask for 2.
Yeah, she's asking for 2 too.
Yeah. So what I do is I just graph the right side first and just kind of duplicate it on the left one.
On the left side.
Yeah. And the count is really important because if you know that you're just adding by 3 over 2, then you just have to subtract by 3 over what?
3 over 2.
Yeah, and you can just go reverse order. Okay. Okay, so let's try a cosine. You pick one. Okay, so now I'm gonna add something on here to make it more challenging. So I'll do like plus um 3. Okay. All right, and let me write up the template. So y equals a cosine bx plus c plus d. So what's a?
A would be the 2 over 3.
Yeah. What's b?
X over 2.
Without the x. It's the number attached to x.
Okay, so 1 over 2.
1 over 2. Yeah. Don't include the x there, okay? And
Okay.
what's c?
Would it just be 1 over 4, or would the pi be
No,
included?
pi's not a letter. Pi's a number. Yeah. So
So
it's negative. Make sure you include the negative. Negative pi over what?
negative pi over 4.
Yeah. And d would equal what?
3.
Okay. So that's my d is always my vertical shift. Okay.
Okay.
All right. Okay. So let's list our informations. So what is our amplitude?
2 over 3.
2 over 3. And what's the equation for period? How do you find your period?
B over C. No, negative C over B.
That's phase shift. Period. 2 pi over.
2 pi over B.
Yep. So b is 1/2. So this is 2 pi over 1 what?
1/2.
Which is what?
Which is 4 pi.
Pi? Okay. And then what do you do immediately after you get your period? You divide it by what?
By 4.
And we call that the count. So 4 pi divided by 4 is simply what?
Pi.
Pi. Good. So that means we're just going to keep on adding by pi, like pi, 2 pi, 3 pi, 4 pi. That's easy. And
Yeah.
then phase shift. What's my equation for phase shift?
Negative C over
E
B.
over B. And what's C? It's going to be negative pi over 4 over 1 what?
Over 1/2.
Okay, so do you see that? Then
Yes.
you have negative, negative, so this is going to turn into a what? Positive? So pi over 4 times 2, right?
Yes.
Which is pi over 2 when you reduce it. Okay. So, and then vertical shift is 3. Okay. Now, when you graph vertical shift on a graph, you always graph that that horizontal line first. So here's 1, 2, 3. So when you see this thing, when you see a graph that says there's like a +3 at the very end,
Okay.
it means you're gonna shift this x-axis 3 spaces up. 1, 2, and what?
1,
3.
2, 3.
So you're gonna put a dotted line at y equals 3 like that.
Okay.
Okay. And you're gonna do all your work on that dotted line. You're not gonna even work with this x-axis anymore.
Okay.
Yeah. So, okay. So we're gonna put all of our numbers here. Now, where do we start? Where's our phase shift? Phase shift is at what?
Pi over 2.
Pi over 2. So it's gonna be somewhere around, right? What? Right there. See it? And
Okay.
I'm gonna put the letter S right on top to remind me I need to start there. Okay?
Okay.
I need to start right there. Okay, now plug in 4 dots to the right. 1, 2, 3, 4. Okay.
Okay.
Now, whenever there's like a shift, I'm just gonna finish the right side first and then draw the left side after, because I need to figure out if I'm gonna like hit this axis here, or if it's gonna cross a little bit over. So I'm just gonna do this first, okay? Okay, so so we gotta count. What's our count? Pi?
Pi, yes.
Okay, so the denominator is a 2, so if I add pi to this, I'll be adding 2 pi over 2, right?
Yes.
So the next one will be what?
It'd be 3 pi over 2.
Yeah, so just keep on adding 2 pi over 2, which will be 5 pi over what?
Over 2.
And then 7 pi over 2. And 9 pi over what?
2.
Okay.
Yes.
And there's no need to, recall it. So watch this. If I start subtracting 3 pi over 2 to the left, I'm sorry, I'm subtracting 2 pi over 2, right? If I subtract 2 pi over 2 from pi over 2, that would pull me over this y-axis to
Yeah.
negative pi over 1. Do you get it?
Yes.
So pi over 2 minus 2 pi over 2 is negative pi over 2. And now I just keep on adding or subtracting 2 pi over 2.
Okay.
Negative 3 pi over 2. Negative 5 pi over 2. We got 1, 2, 3, and 4. Negative 7 pi over what?
Negative 7 pi over 2.
Yeah. Okay. Now let me stop here and ask. Okay, is it slowly making sense?
Yeah,
is it
making a lot more sense.
Yeah, you probably just need to just practice a few more times on your own.
Okay.
But do you see how the count makes everything really easy? Yeah, you don't have to be like, okay, take the period, divide it by 4, find the midpoint, and then do 1/4 of that.
Yeah.
Yeah, so all you do is just take the period, which is 4 pi, divide it by 4, and then just add it to your phase shift. Okay, now again, always make sure you somehow designate where to start, because what ends up happening is students are rushing through their test, they put a dot right there, and they start graphing it like this.
Okay.
They start
Just like
here, and then they're confused because it doesn't quite end at 9 pi over what?
9 pi over
2,
2.
and then they just make things up and then turn it in, and then you get docked off all these points. Okay, so it's gonna start at pi over 2.
Okay.
It's a cosine graph, so what's the amplitude?
2 pi over 3.
No, it's just 2 over 3.
Oh yeah, 2 over 3. Sorry.
Yeah. So what that means is from here, it's gonna go up 2/3. So let's see, 4 will be up here. So 2/3 of that will be like somewhere here. Get it?
So you said 2.
Like 2/3 of the way up. You get it?
Yeah. Would I be able to write just like 2 pi over 3? Or not, sorry, I keep saying 2 pi.
Yeah.
2 over 3. Or do I have
No,
to?
you have to add it to 3. So it'll be 3 and 2/3. You can do that.
Oh, 3. Oh,
And
okay.
then the bottom one will be 2 and 1/3. You get it?
Yes, that makes more sense.
Yeah. Usually we would use improper fractions, but I think your teacher should, do this. Do you remember if she did any vertical shift during class?
I think she might have, but I don't remember.
Well, yeah, you have to make sure it's in reference to this axis, which is 3. Okay?
Okay.
So, okay. All right. So this is a cosine graph. So what are we going to do? What's the pattern? Top, middle, down, middle, top, right?
Okay. Top, middle, down, middle, top.
Yeah. So we're going to start here. Top, is this?
Yes. So top,
middle, down, middle, top. And it'll look like this.
middle, top. Here. Okay.
The left side, we'll go top, middle, down, middle, top. I'm not drawing scale, so it's going to be kind of off. Okay, so there it is.
Top, middle, down, middle, top. Okay.
Yeah. Okay, and then if this happens to be a secant graph instead, y equals 2/3 secant x over 2 minus pi over 4 plus 3, then you would just draw it as if you're drawing a cosine, and then you'll cut it all what?
Into the cereal bowls, and then you just do the opposite.
Exactly, into bowls of cereal. Or I guess you can say cut it in half and then flip it around and put arrows there.
Okay.
Like that. Okay.
And then for the one on the left, can it extend further, or do you just do you ever stop at the dot, or do you always?
Oh, you mean like the top where it kind of ends like that?
Yeah.
You want to extend it all the way down, because I mean you're kind of just stopping the graph there, but the graph technically continues on by itself. Yeah, so you can keep on going. So like right here, I drew it. You see it? I drew it all the way down.
Oh, okay.
Yeah. So some books will graph it like this. Look. So it'll stop right here, and they'll graph it like this, like that. But technically, that's not true because you have to go up to the next asymptote. So it has to go like this. So this side will go all the way what?
All the way down.
Yeah. So the graph just continues on. We're just looking at it as one period of a graph. So if I show you the Desmos graph, cosine or sine, you see this?
Yes.
It just keeps on what?
It just keeps going.
Yeah. And so we're just looking at it and like we're just looking at it as like this. You see it?
Yeah.
So that's one period. Okay. So that's your sine and cosine. Let's do tangent and cotangent and briefly review. Yeah, this is a lot. I know we're trying to fill in like 5 days worth in one hour.
I have another question really quickly. So for when you're doing like the lines for this variable, you draw it on the middles, or do you also draw it on the like the very end? Because I don't know if I just drew it wrong, but
here let me redraw this. So let me see. So we started at 3 right?
Okay, I know it.
That, and then we started it off at pi over what?
Pi
over 2.
Yes.
So 1, 2, 3, 4, and then I graphed it as top, down, or top, middle, down, middle, top, like that.
Okay.
Okay, was your question based on this?
It was based on the lines. I was just a little confused on like I don't know if I drew them in the wrong place.
Oh,
but when
which lines? The vertical lines or this horizontal line?
Vertical lines.
Oh, the vertical lines. Okay, so the vertical lines, whatever connects with the we call this the transaxle.
Okay.
It's called transaxle. The horizontal axis that cuts the graph in half. The vertical lines have to touch that part. You see how?
Okay.
Yeah.
Touching like the middle, right?
Yeah. So I see bowls here. You see this perfect bowl right here?
Yeah.
Yeah.
Okay.
You just flip it upside down like that. And then, okay, so you're asking like, what do you do right here when it kind of stops at the top here, right?
Yeah.
You can just go on and go like this.
So the end of the period, the end of the period would be like the one on the far right. Okay.
Okay, yeah. So here, let me. I think I know what you're asking for. So from here to here is one complete period for my cosine graphs.
So one period. Okay. Yeah. Okay.
But the graph keeps on what?
It keeps going. Yeah.
So as we see here, it just, well, if I zoom out, it just keeps on what?
It just keeps going and going. Okay. Thank you.
Yeah, for drawing purposes, we only want to draw like 1 or 2 periods, so we kind of have to cut it off there.
Yeah.
Okay. All right. Here we go. Tangents. Okay, let's just briefly review the original picture. Do you remember what two numbers this have to be between the asymptotes?
Negative pi over 2 and pi over 2?
Yes, very good. Now, let me show you why those two numbers are so important. Because, okay, now, so graphing this is quite different than graphing the other ones. And this method is like, you're going to just gloss over several steps actually. Whatever's here, okay, whatever's inside the parentheses with x, you want to put that between pi, negative pi over 2 and, and pi over 2. So let me give you an example here. Okay, with this, you're like, oh, okay, tangent. Okay, so again, we know the shape of a tangent is just, it's just the other way actually. It's just that, right?
Yes.
So we just have to figure out which way did those vertical lines go. Well, all you have to do is take whatever's in the parentheses. So repeat after me, whatever's in the parentheses.
Whatever's in the parentheses.
Just put it right between negative pi over 2 and positive pi over 2. Like this. X minus pi over what?
pi over 4.
Yeah. Now there are other ways to do this, but this is literally, I think, in my opinion, the easiest way to graph this. Okay, so watch.
Okay.
All you have to do now is remove pi over 4, so the x can be by itself in the middle like this. Okay, so to do that, you have to add pi over 4 to both sides, right?
Yes.
So it'll be pi over 2 plus pi over 4 on the right, and then pi over 4 minus pi over what? 2 on the left. See it? Now, you just have to suffer through a bit of a fraction here, and you're pretty much done. So on the left side, what would you get? You get 2 pi over 2. No, 2 pi over 4. So pi minus 2 will be negative pi over 4. Okay, do you get that?
Yes, negative pi over 4. And then the other
on the
one.
right, you'll get what?
You have to do 3 pi over 4.
Pi over 4. So when you graph this, right, all you have to do is graph those two numbers. Where's negative pi over 4? Well, somewhere right here. 3 pi over 4 should be a little bit to the right, right? Well, let's graph those two dots, dotted line. Find the middle and just graph. Whoa, and we're done.
Okay. And then I think she said that I need like 5 points to get full credit.
Yeah, so I'll show you how to do that. So what I'm saying is, in terms of graphing it, we're pretty much done. So all we have to do now is figure out these numbers over here, right?
Yeah.
Yeah. So the first number is negative pi over 4. So, okay, well, let's just do this first. Let's just put 2 more dots so that we can, you know. Now, the only problem with this is, I don't know if this red dot is going to touch the y-axis at 0, or if it'll be to the right or to the left. You'll figure it out when we start adding some numbers to this guy here.
Okay.
So, like the previous examples, we need a count, right?
Yes.
Okay, so guess what? Tangents, their period is pi over b, not 2 pi over b.
Okay, so pi over b.
So what's b? What's b here?
B would be the 1 over 4.
No. Okay, look.
1.
So it'd be a tangent bx plus c plus d. So what's b?
1.
1. Okay, so b is always connected to x. So the period is simply just what? Pi over 1, which is just pi, right? Okay, take the period and divide by 4. So count will be pi over what?
Pi over 4.
That's it. So we're going to go to the leftmost number, which happens to be negative pi over 4, and just add pi over what?
Pi over 4.
4 again and again. So if you add negative pi over 4 to if you add positive pi over 4 to negative pi over 4, you get 0. That's your second dot. Add another pi over 4, that's your middle.
Pi over 4.
And then add another pi over 4, that's 2 pi over 4, which you could reduce to pi over what?
Pi over 2.
And then it ends with 3 pi over 4. So there's your 5 numbers.
Okay.
So you see how the count makes things really easy?
Yeah, it makes it a lot easier.
Yeah, you don't need to like work with like, okay, I need to find the distance and find the midpoint and then find the midpoint of those 2 points. Just find the count and just add from the left and to the right. And notice your teacher wants 5 points just by plugging it into this situation right here. We found the 2 endpoints.
Yeah,
we just have to find the middle 3 by adding the what?
The pi over 4.
Oh yeah, the count. Okay, so do you see how this method is really easy?
Yes.
I think the way she might be teaching it, and I've seen this in textbooks, they do like the left side first and then the what? The right
The
side.
right.
You do like 2 different inequalities, right?
Yeah.
It's just easier to just make it into one, and that's it. Let's try another one.
Sorry, I wouldn't need anything on the y-axis, right? Like to line it up better.
Oh, well, remember that semi-amplitude I was talking about, that little 1 right here?
Yeah.
So what you can do is at this red dot, you can go up 1 space and down 1.
Okay, down 1. Okay.
But I don't think that's necessary unless she like wants coordinates. I know some teachers actually want the coordinates for this guy, which will happen to be pi over 2 comma what?
Negative 1.
Yeah, and the left side will be 0 comma negative 1. But you don't remember her asking for these, right?
She wants us to have the coordinates, I think.
For sure, the horizontal axis.
Yeah.
But for
And then I
tangents,
think also wants.
well, I'll just put 1, -1, you know?
Okay. Yeah, just in
so
case.
yeah, just in case. Okay.
Okay.
Here, let's try another tangent. So okay, so here's another tangent.
Okay.
All right, first step, what do we do? Just pull it out and put it next to what?
To the the equation, the y equals
No, I mean the asymptotes.
asymptotes. Okay, so negative pi over 2 is x plus pi over 2. And then you need to subtract negative pi over negative pi, right?
Negative pi, right. So
Oops.
negative pi over 2 minus pi less than x less than pi over 2 minus pi. So negative, okay, did you get that? Negative 3 pi over 2 on the left?
Yes. Negative 3 pi over 2.
2 will be negative pi over 2. Okay, I got these two. Good.
Yes, that's also what I got.
Okay. All right, well, let's find our period. So just get that out of the way. What's our equation for tangents and cotangents?
Pi over b.
Yeah, and what's our b in this case?
It would be
It
1.
would be 1, and then count would be pi
Pi
over
4. 4.
Okay, just have to add that number. Alrighty, so here we go. So these two numbers are my x asymptotes. So
Okay.
now both are negative, so that means it's going to be on the left side, right?
Yes, so negative 3 pi over 2, and then negative pi over 2. And then would I need to leave room for like 4 dots in between?
No, 3, because remember, these two are my end dots. So this is,
yes.
right. So it'd be 1, and then, so, okay, before you do the 3, just always just plot the middle one first, just to find the, just estimate where the middle one is, and then just put 2 right next to it.
Okay.
I'll put this in blue color. So there's your 5 dots. You count it. 1, 2, 3, 4, 5.
Okay.
So the asymptotes are your numbers that she's going to be expecting. Okay.
Okay.
And then what's the number in front of tangent? It's a 1.
So up 1, down 1.
No. So we'll go up 1, down 1.
Okay.
It'll go like this. All right. Now let's find all the numbers. So our count is pi over 4. So we have to add pi over 4 to this guy.
Okay.
So we want to make this into a denominator of 4. So it'll be negative 6 pi over 4, right?
Yes.
Yeah. So let's keep on adding pi over 4 to negative 6 pi over 4. So the next one should be negative 5 pi over 4. Right?
Yes. And then plus another
5 over 4, negative 4 pi over 4, negative 3 pi over 4, and negative, and then it ends with negative 2 pi over 4, huh?
Yes.
Yeah, I think you can reduce the middle one. Negative 4 pi over 4 will become
negative
pi, right? Okay. And there it is.
So up 1 and then down 1.
What time is up? Let's do a cotangent. Okay, now we know the graph for cotangents is very similar to tangents, but it starts at 0 and pi and it goes this way, right?
Yes.
Okay, so what do we do with this x plus pi over 4? We put it down here.
0 is less than
so
x plus pi over 4,
less than
pi.
There you go. All right, so subtract pi over 4 to both sides. We get negative pi over 4 on the left And then pi minus pi over 4 will be 3 pi over 4?
Yes, 3 pi over 4.
Okay. And okay, let's finish up with the period and the count. The period is pi over b.
Pi over b.
B just pi.
Yes.
Count is pi over 4. All right. So okay, now here let's do this. Let's just do all the numbers first and then graph it at the very end. So the leftmost side is negative pi over 4, which we'll put right here.
Negative pi over 4.
The rightmost side is 3 pi over what?
3 pi over 4.
Yep. And okay, so let's see here. So if I keep on adding by pi over 4, the first 1/4 that I'm going to hit is at 0. And then pi over 4. And then 2 pi over 4, which would be pi over 2. And there's my 5 dots.
So pi over 2.
All right.
Oh, I think I left one extra. Oops. Okay.
Okay. All right. So up to this point, it's pretty clear?
Yes, it's making a lot more sense.
Okay. Now, we know the graph is going to go left, up, right, down, right?
Yes.
So let's apply this number here, this 3. So
okay.
What do I do with that one? So at 0, you go up 3 spaces, right?
So up 3 spaces and then down
and
3
spaces. Pi over
spaces.
2, down 3 spaces. 1, 2, 3. And the graph will conveniently go through those 3 points like that.
Okay.
Voila, we are done. Whoa.
No.
Huh?
Number 4. Oh, I was just wondering why. Oh, okay, I see. I put like a big, I guess I just marked the middle point like too big, so I thought it was the dot that I was supposed to make the line.
Okay, got it?
Okay. Yes.
Okay, so let's just try some random ones.
Okay.
Now, okay, so keep this negative in mind right here. So this is negative.
Yes.
And B, this is my letter B right here, right? B is pi over 2. Okay. So again, take whatever's in that parenthesis with your cotangent and put it between 0 and what?
So pi over 2.
Oh, it's cotangent. Yeah. Oh, yeah. So in the middle, you're gonna put pi over 2x.
Oh, okay, pi over 2x. Okay. And then
so we want x to be all by itself. So I'm gonna multiply everything by 2 over pi. Do you get it?
Yes. So by the reciprocal, right?
Right. So pi times 2 over pi, cancel. So you should get like x is between 0 and 2. Get that?
Mm-hmm.
All right. What's your period?
The period would be...
Okay, so be careful with this one. It's pi over b.
Pi over 2, which is
pi over... Wait. So, okay, what's our b again? Oh, pi. You said pi over 2, right?
Yeah.
Yeah. So pi over what?
Which is equal to 2.
Which is equal to 2. And then divide that by what?
Divided by 4.
Divided by 4. So that's our count. So 2 over 4 equals 1 what?
1/2. And then...
All right. So I think we have enough to graph.
Mm-hmm.
So draw your asymptotes at 0 and 1 and 2. And this is easy to kind of scale, right? So pretty obvious.
Yeah.
1/2 and 3 what? 3/4? Yeah. So you just keep on adding by 1/2. 1/2 is 1, 3. Yeah, 3/4 and then 4/4.
1/2.
And okay, so now the number in the front, the coefficient is -3. So cotangent graphs will do this, right? So if it's negative, it's got to go the other way.
The opposite way?
Yeah. So right up. So so the negative cotangent acts like a tangent. You see that?
Yeah.
Okay, but now so let's apply this 3 right here. So we're gonna go up 3 at 3/4 and down 3 at 1/2. You see it?
Yes.
And then graph it. Voila.
So up 3 at 1/2. Oh no, down 3 at 1/2. Okay, down 3 at 1/2.
Yeah.
And then up 3 at 3/4.
Okie dokie. Got it?
That makes a lot more sense.
Okay, and I'll send you the link to this video so you can just scroll back and forth and review.
Thank you so much.
I think that's it. You're welcome. Have a good weekend.
You too. Bye.